So, quiz 3. Draw the mechanism and resonance arrows to form the 3 different carbocation intermediates. And then I want you to draw the mechanism arrows to show the product formations for A, B, and C intermediates. Okay. So what you needed to do here was really just take your time and have the pi bonds react with the H plus, and actually it's the same pi bond reacts twice. Some people did like a hydride shift, which was fine. That wasn't exactly what I was looking for. Like, so there's a pi bond missing there. But that's okay. People did things reasonably well. So the first step, pi bond reacts, right? So you maybe notice that this one, if you numbered everything, this sulfur ends up on this carbon of the pi bond. So pi bond reacts, make a carbocation there. Sulfur adds, right? Sulfur adds there. Proton transfer, and we get to the first product A. The other 2 products, B and C, and some people did this nice. They showed like 8 intermediates, A, B, and C. That's cool too. Proton transfer, add the pi bond reacts with the H plus. You put the carbocation now on the other side. This was a tertiary carbocation. This is a tertiary doubly allylic carbocation. So this is probably the more likely product. But what you can see as you do this, the pi bonds, you need to do some resonance. And that can get you, if you do 1 pi bond over, that gets you to the plus charge on this carbon here. Sulfur adds in. Proton transfer, that's product C. If you come here, if you did 2 arrows, 2 resonance arrows, you could have, you didn't have to do 2, you could have done it 1 at a time. You get the plus charge here, another tertiary allylic carbocation. Sulfur adds, proton transfer. Biggest things people forgot to do is balancing their charges, right? Maybe numbering their atoms, but most people did pretty well on this one. All right, so number 2, draw the product and mechanism arrows for the reactions below. So here we have this is called a carbamate. You wouldn't know that, but that's a carbamate. It's not an amide, it's not an ester, it's a carbamate. So carbonyl with 2 leaving groups on either side. Wanted to have, you have an excess Grignard reagent. So this is your nucleophile, right? There's a carbon with a negative charge, essentially, next to bonded magnesium in excess. So you're going to keep adding this until you can't add it anymore. And then finally, you're going to add H+. Try to give you the hints here that this is an alcohol. This is an amino alcohol, meaning that there's a nitrogen, an NH, and an OH on this side. All right? So the first step that happens, you add in, the Grignard adds in, make a tetrahedral intermediate. You need to eliminate the best leaving group. The best leaving group actually is the O minus. I think everybody pretty much did that. I was worried that somebody might kick out the nitrogen first, but the O minus is the better leaving group, so you do that one first. So now you've made an ester, and again you gotta slow down here because you don't, right? At this point, you do not protonate at this point. You're still in basic conditions, right? So yes, there is a magnesium plus here that I didn't draw. It's okay. Another Grignard adds in, another tetrahedral intermediate, kicks out the nitrogen. So now you have this nitrogen that's like this. I guess I added there at the end. That's fine. I was getting lazy, right? That gets protonated. But then we made this another ketone. Another Grignard adds in, get a tetrahedral intermediate, and this gets protonated too. So the final step is all the 3 all the things adding to the protons, right? Should be separate steps, and that gets you to, right, this tertiary alcohol and this amino alcohol type of structure. Biggest things for this, keep adding the nucleophile until you can't add it, until you don't have any leaving groups left, right? You're going to add it to the pi bond, make a tetrahedral intermediate, right? Something that goes from sp2 to sp3. Do I have a good leaving group? If you do, make a new pi bond, kick out the leaving group, and then keep adding stuff. Right? Keep adding stuff until you can't anymore.